In this lesson, I will explain to you about measures of variation, and this is one of the most important topic in statistics. In this lesson, our learning objectives are spread or variability of a data. So we will see how data spreads if we have a data set available, and we will find out the variability of the data set. So we will learn in this lesson how to calculate the range, how to calculate the variance and standard deviations. In the last lessons, we have learned measure of central tendency. If we want to find out the average, then we use mean, median, mode, mid-range and weighted mean, and these are called the measure of central tendency. If we need more accurate result, then we have to use measure of variations. With the help of central tendency, measure of central tendency, we can also make some conclusions. These are also fine, but statisticians use measure of variations instead of measure of central tendency if you need more accurate data. So measure of variations, we have range, variance and standard deviations. So if someone asks you what is central tendency and what is the measure of variations, measure of central tendency we use to find out the mean. So these are the or averages. So these are the method to find out the central tendency, and these are the methods to find out the measure of variation. See, the name indicates variation. So we will see that how our data varies in the question. So I have taken this example here. This is the light bulb, very simple example. I have taken two bulbs. One is called the brand A and the second is brand B. And these represents weeks. So brand A first bulb lasts for 20 weeks. Second bulb lasts for 34 weeks. Similarly, third bulb lasts for 30 weeks and then it fuse and so on. And these are the weeks for brand B. Brand B, the first bulb lasts for 10 weeks. Similarly, the second lasts for 20 weeks, 30 weeks, 40 weeks, and so on. If someone will ask you to make some conclusions or what brand you will buy, brand A, brand B, with the help of this data, so we cannot make any conclusions because this is the raw data, right? So here we are calculating, we are using measure of variability or variance or standard deviations in these example. So you have to see this. That's for the brand B. The minimum weeks is 10 weeks and the largest means or the highest amount is 60 weeks. The bulb lasts for 60 weeks. Here 20 weeks. The brand A bulb lasts for 20 weeks, maximum 55 weeks, right? So if we take the average or mean of these two, and this is the population. What does population means? Because see, we have 7 bulbs, 1 2 3 4 5 6 7, and we are taking 7 into consideration. Here we have 7, we are taking 7 into consideration, so this is called the population. If I will randomly select, suppose this or this, right? So these are called the sample. So in this lesson, we are going to learn how to calculate the variance and standard deviation of population. Population means we have to consider each and every value, right? So mu represents the mean of the population, while x bar represents the mean of the sample. In this lesson we will use population. Mu is the mean for population, then sigma x divided by n. Keep in mind, in population when we calculate the mean, you have to divide it by capital N, because I will show you when we will move to the sample that here we have to use small n minus 1. So keep in mind, this is capital N. Summation of x divided by capital N. What does it mean? Summation of this 20 plus 34 plus 30 plus 35. Make the total n divided by 7 because we have 7 observations. Similarly, make the total, add all these numbers divided by 7 and we have seen the total is 259. So this is called the submission sign. Total submission of x, x is the data values, and this is the number of observations. We have 7, so we have 37 weeks here, 37 weeks here. We have calculated the mean of both brands, and then we conclude that both have 37 weeks. On the basis of mean, you can say we can pick any brand, but if you will see the variability is different. 10, 20, 30, 40, here 20, 34, 30, and then 35. So variability is different. On the basis of mean, we can say that you can buy either brand A or brand B, but this is variance and standard deviation, and you have to see the variability of the data, right? How your data varies. If we see the same scenario with the graphically, so we have seen in brand A, our minimum, there are 20 minimum weeks and maximum weeks are 50. So our data lies, so variability is between 20 to 55. But for brand B, the variability starts from 10 weeks to 60 weeks. So see, data varies from 10 to 60. Here data varies from here to here. So this is totally different result. Means are fine, that is equal, but graphically, see, if we calculate the variance or standard deviation, if your data is more variable, then you do not have to consider. On the basis of variability, we have seen that brand B is not good because its data is too vary, and here mean is same. That is why statisticians use measure of variations in order to describe the data set more accurately. More meaningful, statisticians use measure of variations, and these are range, variance, and standard deviations. Okay, now uses of variance and standard deviations. What are the uses? To determine the most important use of variance. See, the name indicates variance and standard deviation to determine the spread of the data or variability of the data. To determine the consistency of variable, to determine the number of data values that fall within the specified interval in the distribution. This point I have explained in the Chebyshev's theorem and used in inferential statistics. Inferential statistics means that we make decision on the basis of hypothesis or estimation. But the most important point of variance is to find out or to determine the spread of the data or variability of the data. So first measure of variation is range, right? Range is very simple. You have to find out the highest number from the data and the lowest number. So suppose these are the numbers, 90 is the highest, 10 is the lowest. So we will make a difference. Range is 80. So I have calculated the range of the same example, light bulb example, range of brand A and range of brand B. So see, the highest range of brand A is the bulb lasts for 55 weeks and the lowest is 20 weeks. So difference is 35. For brand B, the highest is 60, means the bulb lasts for 60 weeks, lowest 10 weeks, so difference is 50. So what we conclude on the basis of range, it concludes that 35 weeks separate the largest data value from the lowest data value. So in this case, this data has less variability compared to this one. It is the difference is 50 weeks separate the largest data value from the lowest data value. So if the data is more variable, then we have to consider the other one which is less variable. On the basis of range, we can say that we have to buy brand A. Even means were same, averages were same, that was 37 weeks, but on the basis of range, on the basis of measure of variations, the first is range. On the basis of range, we can say 35 is fine because it is less variable than B. But in order to get more meaningful results or more correct results, now we will use variance and standard deviation. Range is also fine, but variance and standard deviation will give us more accurate or meaningful results. So population variance and standard deviations, I told you population, if you will consider each and every value, suppose we have 10 students in the class and we are taking 10 into consideration, 10 students are doing the teacher's evaluation, right? It is called the population. If I select randomly 4 or 5 students, then it is called the sample. So population, we have to calculate the variance and standard deviation of population and variance and standard deviation of sample. But in this lesson, I will show you how to calculate the variance and standard deviation of population. In the next lesson, we will discuss sample variance and standard deviation, which is part 2 of measure of variations. After this, please watch that movie as well, then it will be more clear to you. So population means we have to consider each and every value. So in our light bulb examples, we have seven data values for brand A, 7 data values from brand B. So we have to consider each and every value, that is called the population. Now, how to calculate the variance and standard deviation, population standard deviation? There are 6 steps, but these are very, very easy. It seems that it is difficult, but it is very easy. First step is find the mean of the data which we already calculated, that is 37 weeks. So how to calculate mean? See, you have to see mean of sample or mean of population. So this is population means we are considering all values. So the mean of population is represented by mu. This is mu is summation of x divided by capital N, and we have calculated 37 weeks. I will show you in the next slide as well. This is the first step. In order to calculate the variance and standard deviation of population, first step is you have to calculate the mean, and this is the formula of the mean. If it is sample, then you have to use x bar, but this is mu, population 37, right? Find the deviation for each data value. Deviation means how each value is far from the mean. In our first example, suppose we have 10 weeks, then 34 weeks, then 37 weeks. So individually, this is x. You have to minus 10 minus 37, then 34 minus 37. Whatever data values you have, individually one by one you have to subtract from the mean. This is right. This data value minus mu. This data value minus mu. So this is what is the deviation means, how far this data value is from the mean. So if the answer is minus 27, so we will say minus 27, it is far from the mu, the first data value. But keep in mind, this is very important point. Always when you will subtract x data value minus mu mean, always you will get 0 at the end. When we will make the total, always you will get 0, and if it is 0 we cannot move further. That is why we make the square. This is the reason we make the square. X in third step is x minus mu whole square. You have to make the square of it. Why? Because always second step will be 0, always. So if it is minus 27, then we make the square. Minus 27 minus 27, it will be positive, around 750 or whatever, right? So in order to get some answer, we will make the square of it, square each of the deviations. Then we have to make the total, sum the square, and then we divide by n. This is capital N in case of population, and we have in this case 7, so we have to divide it by 7. And this is the variance. Variance is represented by sigma square. Why sigma square? Because we have made this square, that is why square. And the sixth step is we have to take the square root of the variance. The we have to take the square root of the step number 5. Why we are taking the square root, making sigma? Because again this is very important point, because we made this square. Actually in the question was not it was not a square, we made the square of x minus mu square. So in order to make the unit as it was in the raw data, we have to take the square root, that is called the standard deviation. So these 6 steps we have to take in order to find out the variance and population. First is you have to calculate the mean, then individual value minus mean, always it will be 0. Then you have to make the square, then make the total divided by the total number of observations and take the square root. What does the variation means, right? I told you variation means how your data value is far from the mean. It is the difference or distance each data value each from the mean. We have 10 minus mu 27, 20 minus whatever the mean, 30 minus the difference is called the deviation. In the light bulb example, the mean for brand A is 37 weeks. It means mu is 37 weeks. Now, specific bulb, take the specific bulb that lasts for 45 weeks. So we will say 45 minus 37 is equal to 8 weeks. So this is the deviation. How far individual value from the mean is, it is 8 weeks. If we find the sum of the deviations, means in individually x minus this, x minus mu, always you will get 0. This is very important point. This is step number 2. After mean, when you subtract individual value minus mu, always you will get 0. That is why we sum the square and find the mean of squares by dividing n. Here I have mentioned the population variance, how to calculate the population variance and standard deviation. Step number 5, step number 6. What is population variance? Variance, right, is the average of the squares of the distance. Whatever is sum is, right, x minus mu, you have to make the square of it. Why square? Otherwise it will be always 0. So we have to make the square, then we have to make the total of all the observations. That is, this is called summation. So the square of the distance, each value is from the mean, x minus mu, each value from the mean, square, and you have to make the total and divided by n. Population variance symbol, Greek letter sigma square. Why square? Because we have made this square. In the question it was only x minus mu. Why we made it square? Because otherwise always you will get 0 answer. So sigma square is equal to summation of x minus mu whole square. And again keep in mind capital N, because in the next lesson we will use a small n in sample. And standard deviation, you have to take the square root of this figure. Whatever is here is the square root of the variance sigma. Population standard deviation symbol sigma, right? This is for, and for the sample we will use S, but here this is sigma for population and mu is the mean for population. Okay, now here we will discuss the same question, bulb. So in this way you will learn more. This is our data. 20, first bulb lasts 20 weeks, then 34, then 30 and so on. So what is the first step? You have to take the mean of this. And what is the formula? Mu sigma x, and you have to add all this divided by 7. So this is the first step, 37 weeks. Average is 37 weeks. What is the second step? Individually you have to subtract this data value from 37, this 37, 30 minus 37, see 20 minus 37 minus 17, 34 minus 37 minus 3 and so on. But I told you x minus mu, always you will see the answer is 0. You can see minus 17, minus 3, minus 20, minus 27, minus 29. These all are negative. But this is 18, 3 and 8, which is positive 29. And this is minus or negative 29. So always it is 0. Subtract the mean from each data value. This is the important step. That is why you have to take the square. If I take the square of this minus 3, 9, minus 7, minus 7, 49, minus 2. So third step is square each value. This is the answer. You have to make the square. Square means then you will get rid of this negative sign, and then all you have this positive, and then make the total 289 plus 9 plus 49 and so on. So this is 748. Find the sum of the square. These are already squares, so this means summation. This is summation, sum. You have to add this and this 4, so it is 748. What is the fifth step? Then you have to divide it by 7. So when you divide it, this is called the sigma square, variance, right? This is the variance, 106.8. This is the variance, and now you have to take the square root of 106, which is approximately, this is the approximately sign, this is equal to sign, so approximately equal to 10.38, maybe it is 10.37 or 10.39, approximately 10.38. Why we have taken this square root? Because here we had made this square. Now, in order to get the same unit as it was in the raw data, you have to take the square root. Again, this is very important thing. So this is the variance, and when you take the square root of the variance, it is called the standard deviations. So this is for brand A. Keep in mind. So in brand A, our standard deviation is 10.38. We will make our decision on the basis of standard deviations, means how your data varies. So if you have a more variation, then we do not have to select that data. So this is for the brand B. This is our data. Same 6 step. First we have to take the mean. Mean is same 37. Then second is you have to subtract 10 minus 37, 20 minus 37. Individual data values you have to subtract mu, and you will see when you will add all these values, you will see again it is 0. Step number 2, always be 0, right? So we have to take the square in order to remove this minus sign, then we will get some things. So this is square. We make the square of it, it is 1918, then divided by 7, because this is the variance. Divide the sum by n, and square root approximately is equal to 16.55. So we can say that in case of brand B, our data is more variable compared to brand A. So we have to prefer brand A, as the standard deviation of brand A is 10.8 and for brand is 16.55. The data of brand B is more variable compared to brand A. And this is important point. When the means are equal, just in our case, the larger the variance or standard deviation is, the more variable the data is. And these are very important note. In finding the square root, always use positive values, as variance and standard deviations can never be negative. So in our first exam, this one we had 274, it was positive. This is 106, it is also positive. So this is the important point, that you have to take always positive, because variance and standard deviation can never be a negative. Second thing is, I told you already why we take the square root of the variance. The reason to take the square root is that since the distance were squared, why we made the square? Because you will get 0 answer always in step number 2. That is why we have to square the distance. The unit of the resultant numbers are the squares of the units of the original raw data. Finding the square root of the variance, put the standard deviation in the same units as the raw data. So in this lesson, you have learned measure of variations, range, variance, and standard deviations of the population. In the next lesson, next video, I will show you how to calculate the range, standard deviation, and variance of sample. So if still you have any question, you can write down in comment section. But please do not forget to subscribe to my channel, Saima Academy. Thanks for watching.